This is Mr. Ashton going through the first PPE that we did last week. By all means, scan through to the questions. If you know you got these right, you don't need to listen to me talking through them. By all means, just scan straight through. The first question says, calculate the probability that on a randomly chosen day, Alan has fruit at lunchtime. Now, that's the only one that's empty. Now, he has one of these things here. All of them must add up to 1. So that means if I add up the 0.5, the 0.18 and the 0.27, I get an answer of 0.95. So if I do 1 take away the 0.95, that leaves me an answer with 0.05. So that's what my answer was there. It says, what is the probability that on a randomly chosen day he has either tea or mineral water at lunchtime? So tea or mineral water, that's those two probabilities. Now if I'm having either of them, what I do is I add the two numbers together, and again in some respects I should have laid this out slightly differently. Maybe that would have been a better way to do it, so I get 0.45, but make sure your answer stands out really nice and clearly. Don't have it sort of tucking away. Look at that, so I can make sure someone marking my work can see it really clearly. And then the final question says, what is the probability that on a randomly chosen day of the week, Alan has coffee on the Tuesday and then tea on the Friday? So the chance of him having coffee is 0.5, and then the chance of him having tea is 0.18. Now, the rule that we have it on 2 different days is not that we add them together, it's that we actually multiply them together. Now, there's 1 mark just for making that statement. Now, 0.5 times 0.18, I've got no idea what that is, but I know what 5 times 18 is. 5 times 18 is 90. But to do that, I made that 10 times smaller. And to do that, I actually made it 100 times smaller. So what I need to do to that answer is actually make it 1,000 times smaller to go back this way here. And that cancels out the dividing that by 10, dividing that by 100. So dividing it by 1,000 will give me the answer 0.090, or just 0.09 would have been acceptable here. Okay, so that answer would have been absolutely fine. Okay, question 2. Okay, now this was a little bit fussy. It was only 1 mark, which I thought was a little bit mean, as it was easy to go wrong here. Although, mind you, it wasn't a negative, so it wasn't the worst one I've ever seen. So what I do is I change the x for open brackets, and I chuck in the value of x, which is 2, into there. So that was squared. I missed a squared then. 2. So 2 squared is 4. 4 times 3 is 12. Take away 4 times 2, which is 8, and then take away 10 from that. So that should give me the answer -6. On the graph paper opposite, draw the graph of this thing here. Okay, so I'm going to have a look at the graph paper now and draw it at the same time. Now, quite a few mistakes going here, so people losing 1 mark, certainly in my class. Just be careful when you're plotting that graph. As long as you plotted the values that you had, even if you had that wrong, you couldn't lose this mark, as long as you plotted it correctly. So -2 and 10, so that's this point here, and then -1 and then -3, so -1, -3 here, and then 0, 10. Now, what I had a lot of people in my class doing at that 0, 10 point is they didn't actually draw through it. And you plotted it, but you didn't actually draw through it. So just be careful that you actually plot through that. And then -1 and then -11 there. And then 2 and -6. So 2 and -6 there. And then 3 and 5. So 3 and 5. So just check whenever you've got an x squared graph. It should be doing this sort of like U shape here. If you had that point like jumping up there, that should be an indication that you've subbed in wrong. Okay, so just be careful if that's the case. So now drawing that graph, it should be a smooth curve. You shouldn't sketch it. It's going to be hard for me because I've got my computer and a cup of tea around everything, but I'll try my best for you to see me doing it. So I'm going to go through there. You can see already I've managed to make a mistake there. Okay, coming up something like this. Now, it's fine to extend this graph going up here. That's what it should be doing. I'd expect it to come up through there. Like I said, I'd prefer it if this was a bit neater. Yeah, that'd be a better curve. Second one I drew. Now, if I had a rubber like I should do, like I'm sure you do in your pencil cases ready for the exams, I'd rub that line out and make sure it looks pretty neat. Okay. It then said, I'm going to have to look at my graph for this, it then said, Using your graph, write down for the values where of x when y is 0. Now, we're talking about where it crosses the x-axis. That's when y is 0. If you come off and read here, the value of y is 0 here and here. Now, as long as it's off your graph, it's fine. You might have a slightly different answer to me, minus 1.1, 2, 3, 4. So for me, one of the answers is minus 1.4. And the other answer for me is, now I'm coming to 3 and counting back, 0.9, 0.8, 0.7, 0.6, 2.6. Okay, as long as they were whatever your graph showed, you couldn't not get the marks there. Okay, now this question here, a little bit sneaky what it was asking for. It was asking for what's called the minimum point of the graph, where the gradient is 0. Now the gradient is 0 of this graph, where it's not coming down or going up, where it's flat. So it's around here for me, somewhere around here. Okay, so it says, give the coordinates of the point of the curve which the y values stop decreasing and begin to increase. Give each coordinate to correct to one decimal place. So for me, I think that makes it there, but as long as you made it clear where your graph was, like I said, it doesn't matter where it was as long as yours was true with what you said. I make mine 0.8 and just under minus 11, maybe a minus 11.2. So x was 0.8 and y was minus 11.2. Now just be very careful, one or two people actually swapping those two values over and I can't give you any marks, that just be careful, okay? It then says, if you needed to draw the graph of y equals 3x squared minus 4x minus 10 from the values of minus 3 to 4, which we just plotted it from minus 3 to 3, didn't we, or minus 2 to 3, using the same size of graph paper, what would you need to alter on the graph? Now on the graph I can quite clearly see that for my answer for 4, look, it's shooting up, that's what I'm expecting the graph to do. I can't plot it unless that y-axis changes, so maybe have that going at 4 and then 8 and so on, okay? But all you need to say here was change the scale on the y-axis. Okay, that would have got you the marks. Change the scale on the y-axis. Okay, so next question. Okay, now what too many people did wrong on this was they didn't actually show or give a full explanation. So it says a squared plus b squared is always an even number when a and b are whole numbers. True or false? Well, the best thing to do is to do a test on that. Okay, so let's try a whole number. So let's try 1 squared plus 2 squared. So 1 squared would be 1 plus 2 squared, which would be 4, which is then equal to 5. Well, that already contradicts it, doesn't it? Is always an even number when a and b are whole numbers. So if a and b are whole numbers, which they were in this case, that's not true. So the reason why, so that's false. The reason why was an even number squared. So this was my 2. An even number squared is going to be 2 times 2. That will always be equal to an even. Okay, always. Whereas an odd number squared, so 1 squared, and I can show you the few others, and this is what you might need to do in the exam, would be 9, 5 squared would be 25. They're always odd. Odd squares are always odd. Now if you do an even, add an odd, it means your answer will always be odd. So if you think of that on a number line, so we've got even, odd, odd. Let's say I'm on the even number here and I add an odd number. Let's just say it's add 1. It's going to shift me up to an odd number. And the same will be true if I added 3. I would have done 3 jumps and that would have taken me odd, even, odd. And it will always be the case if I'm on an even number and I add an odd number, I'll end up on an odd number. Okay? If I had an even number and I added an even number, it would always be even. Now this thing here, a squared plus b squared, and it says is always an odd number when a and b are odd numbers. So check that you're actually doing what it says here. I can't choose 1 and 2 this time because 2 is even. So I'm going to say 3 squared is equal to 9, and then 5 squared is equal to 25. Okay. Now a squared b squared means that you're multiplying these two together. So 25 times 9. No idea. Haven't got a calculator, not allowed to use one. 25 times 10, I know that. That's 250. Take away 25 is 225. So that means that an odd number times by an odd number is equaling an odd number. Let's just do another check before I take that for certain. So odd times an odd, so let me think of another odd number. So let's say 3 times 7 is 21. Yeah, odd again. 5 times 11 is 55. Yeah, look, it's always true. Odd times odd is an odd. Okay, but now I need to say why this is true. So I can't just circle true and say, look, that's my answer. I know that if I have an odd number and I square it, that's going to do odd times odd is always odd. And then that's going to give me an odd number there times by another odd number there, and I've just stated that an odd times an odd is always odd. Okay, so how I would write that out is odd squared is always odd, then odd times by an odd is always equal to odd as well. Okay, so that's what we're looking for in terms of saying that. It wasn't like a Q or an OCW question like the next question, so I don't need to go into like massive full detail, don't need to write a full paragraph there, but maybe I could write a little bit more to see what I'm saying. So odd squared means times by itself, meaning odd is equal to odd, which is always going to give me an odd number. Okay. Number 4, now this was, if I did this around your work, this meant that you didn't really pay enough attention to that, okay? There's lots of marks to be gained here. Keywords in the question. Prove that it's always possible for a square. Now square, you know stuff about that. Those angles are all 90, aren't they? So I can put that in straight away. A regular pentagon, now we need to know what that is, and a regular hexagon, we need to know what that is. An isosceles triangle, so they've been a bit kind here, they don't need to put 69 in both of those, they could have just put 1 and expected you to know that one was 69. Meet at a point. Okay, now I need to go and work out the missing angle in the triangle, so I'm going to say isosceles triangle. I'm just going to state what I'm doing as I'm going along. Isosceles triangle, that's the two angles that I know added together. So 9 add 9 is 18, and then 6 add 6 is 12, add that is 138, and then 180, take away that, will give me an answer of 42. That tells me this angle here is 42 degrees, okay? But if it says OCW, you shouldn't just have calculations coming out of nowhere. Say what you're doing. So I'm add together known angles, and then take from 180 to find missing angle. Okay, now then, let's look at the regular hexagon, let's look at the regular pentagon, these two guys, okay? Formula you need to know. 180 times by n minus 2 will tell you the angles in an what we call an n-sided shape. So if it had 5 sides, like the pentagon, 5 take away 2 is 3, so 180 times by 3 will tell me the degrees in that shape. If it had 6 sides, like in a hexagon, 6 take away 2 is 4, 180 times by 4 is 720, that's the angles in the hexagon. Okay. Now the reason why that's happening is basically, if I did a very, you wouldn't need to write this in the exam, this is just for you if you're unsure, is if I have a pentagon, I can chop it into 3 triangles. 1, 2, 3. That 3 is 2 less than the number of sides. And if I drew a hexagon here, if I chop that into triangles, 1, 2, and then that into 1, 2, 3, 4. Four triangles, there were 6 sides, so it's just saying it's always 2 less than the number of sides, which is true. Okay, so regular pentagon would be 180 times by 3. If needs be, set it up like this instead. 0 times by 3 is 0, 8 times by 3 is 24, 1 times by 3 is 3, add the 2 is 540. But the word regular means all the angles are the same. So I would do 540 divided by 5, and I just state here to find one angle. And then 540, how many 5s go into 500? 100, and then 5s into 40 is 8, so it's 108 degrees. So I know that is 108 degrees. Okay, and finally, regular hexagon would be 180 times by 4, 2 less than the number of sides using that formula. So then 0 times by 4, 0, 8 times by 4 is 32, and then 1 times by 4 is 4, add the 3 is 7, and then I would do 720 divided by 6 because there are 6 angles in the hexagon. Regular means they're all the same. How many 6s go into 72? 12, add the 0 on the end, so I know that is 120. Now, if these really do fit together at a point, all of those should add up to 360 to find one angle in, I'm going to say, in pentagon and hexagon. just so I'm explaining where those calculations have come from. So by doing, I'm going to do this from smallest to big, or from biggest to smallest. 120, add 108, add the 90, and add the 42. So add those together. What do I get? 8 add 2 is 10, and then 1 add 9, add the 4, add the 2 is 16, and then carry the 1, 1 add 1, 1 is 3. Okay, all angles add to 360 degrees, which means they tessellate, which means they all fit together perfectly because they all meet together at a point. So it means that because they fit snugly, there's no single gap left, meaning that they all fit together, which is what this thing called tessellation is called. If it was 359, they wouldn't have tessellated. If it's 361, they wouldn't have tessellated. It had to be spot on 360 degrees. Okay, over the page. Lots of people getting these ones wrong, so take your times. It says the gradient of the line. We know when we're talking gradients, we've got to have it in the form y equals mx plus c. If you want to do some writing around by the side of this, not a problem at all. That's not in the form y equals mx plus c. I need to take that 2 over, so it will become a divide by 2, so y is equal to 4x plus 3, all divided by 2. Now what I can do from here is individually divide both those by 2, so I get 2x plus 3 divided by 2, which I'm going to leave as 3 divided by 2, but I could say plus 1.5. So the gradient is 2 because that's what the number in front of the x would have been when it's in the form y equals. This one here says this one crosses the x-axis. Now again, I need to have it in the form y equals mx plus c. That is my intercept, that bit there, and this thing here is my gradient. Well, I've just gone and found the gradient, now I'm just going to go and do exactly the same thing, but I'm going to find the y-intercept. So y would be equal to 5x minus 6 all over 3, and again I'm going to individually divide those by 3 to get 5 over 3x, and then minus 2, so that one there. Okay, and then finally here, the line y equals 3x minus 2 has a point with the coordinates 3, 2. Well, all I need to do is sub in those numbers into that and see if it works. If it doesn't work, then it's not true. So x is equal to 3. So I'm just going to chuck in x equals 3. So y would be equal to 3 lots of 3, take away 2. What is 3 lots of 3? That's 9. Take away 2, y is 7. No, it says here y is 2, so that one doesn't work. Same one here. So I'm going to chuck in x is equal to 0 this time. So y is equal to 3 lots of 0 minus 2. 3 times 0 is 0. Take away 2 is minus 2. That's not what I've got there. I've just got positive 2, so it doesn't work. And then y equals 3 lots of minus 3. And then minus 2. So that is going to give me minus 9. And then minus 2 would be minus 11. No, it says 2. And then y equals 3 lots of 2. Take away 2, so that would be 6. Take away 2, y is 5, so it's not that one either. So by process of elimination, it must be this. Let's just double check. So y equals 3 lots of 3, because x is 3. Take away 2. 3 times 3 is 9. 9 take away 2 is 7. It is that one, because that's what my y is there. That was really irritating having to go through all of them. Just pot luck that it was the one at the end. I could have started at the end and I would have actually been there an awful lot quicker. This was pretty tricky. In standard form, okay, so what we need to do, we need to change that bottom number to being in standard form. Okay, so what you should do is you should be able to change that between a number between 1 and 10, which would be 6, times 10 to the 3. Now I'm going to let the numbers deal with the numbers and the tens deal with the tens. So the first thing is I know I'm going to have 10 to the power of 7, because in standard form, when you have the powers, you just subtract the powers. 2.7 divided by 6, no idea. So I'm going to bus stop method, chuck it in. How many 6s go into 2? 0. Decimal point up here. I like to cross the 2 out and carry it over. How many 6s go into 27? 4. Remainder 3. Now this number after a decimal point would just be zeros. Those zeros keep on coming along, so that's not really 3, that's 30. And how many 6s go into that is 5. So my answer at first glance is 0.45 times by 10 to the 7. From there, I need to change this. This has to be a number between 1 and 10. The way I do that is I just times it by 10. But if I've times that by 10, I can't just say that I've got a number, times it by 10, or now it's 10 times bigger. I'd have to divide this by 10 to cancel it out. So for instance, if I said, what's your age? And you said 15. I said, oh, let's make that 10 times bigger. You're now 150, it doesn't work. It's not the same thing. If I made it 10 times bigger but then 10 times smaller, you'd just be back to what you were. Okay, so I have to do its inverse operation here. If I'm dividing by 10, that's really got an indice, which is 1. I'd subtract 1 from the 7, so it'd be 4.5 times 10 to the 6. I'm going to do a very, very similar job here, but this time it's timesing, so I'm doing 4.5 times 3, so I'm just counting in 4.5, so double it would be 9, add on 4.5 would be 13.5 times 10. Okay, so we're on minus 2 and we're adding minus 3, so that's actually minus 5. Again, that number is not between 1 and 10, so I'm going to divide this by 10, but to counter that out, I'm going to times this one by 10, so that gives me 1.35 times 10 to the minus, now just be careful here, minus 5 add 1 would be minus 4. Okay? Number 7. For a particular visitor to Gwynedd, taking a trip at Snowdon is an independent, and that just means not affected. So if I've done that, it doesn't mean that I'm less likely to do this, okay? It says the probability that a visitor takes a trip at Snowdon and visits the castle is 0.12. So that's that one, then that one. So I know 0.4 times by something has got to equal 0.12. That 0.12 should not have gone there. A few of you did that. 0.4 times what makes that? The answer is 0.3. So that tells me that one is 0.3. These branches have to add up to 1, so that must be 0.7. Because they're independent, I can repeat these probabilities here and here. And then here would be 0.6 because 0.4 add 0.6 is 1. Okay, so that would have got me the 4 marks. It then says calculate the probability that a visitor does not go up Snowdon, and does not go up Caernarvon Castle. So that's no, then no again. So that would be 0.6 multiplied by 0.7. Show your work and don't just have it jump out of nowhere. Show where that answer's come from. There would have been a mark for that. If you had accidentally got these wrong, but you just showed that times that, you'd still get one of those 2 marks. Okay, over the page. Okay, loads of people making a mistake on this. Be very, very careful, please. We don't like this over 3 bit here, so we're going to take that over to the other side, where it's going to times the other side by 3. But that is both things on the other side. And the way we do that is we write it in a bracket, okay? Or you could just times by 3 in one go. So that would give me 8 minus x is equal to 15 minus 3x. Okay, the way I solve these, I look for the smallest x. That is minus 3. Minus 3 is smaller than minus 1. Okay, so I'm going to take this over to this side and get anything without x over to this side. So that is going to give me now plus 3x minus x is equal to 15 and then minus 8. 3x take away x is 2x, and then 15 minus 8 is 7, and then x it would be equal to 7 divided by 2, which is 3.5. Okay. Factorize here. Now to factorize, I have to take the highest common factor outside of the bracket. To do that, I might need to take a number, I might need to take a letter, I might need to take both. Biggest number that goes into 6 and 8 is 2. A squared and a means a would come out of that. Now a, because that one only has this an a, I can't go a squared because that one hasn't got an a squared in it. B is only in that one, not in this one. So now brackets, 3 because 2 times 3 makes 6, and then a because a times a would make a squared, minus, and then 4 because 4 times 2a would make 8a, but I've got a b as well, so it needs to be 3a minus 4b. Finally, with this one here, very similar to standard form, if you have the same answer there and there, you can just subtract these indices. So all we needed to get the 1 mark was exactly the same bracket. That does not change 1 iota, and then 6 take away 3, not 6 divided by 3, 6 take away 3 to get that bracket to the power of 3. Okay. Next one. Okay, right, I need a ruler for this, which I probably should have got in hindsight. Give me one very brief moment. In fact, actually, I'll just use this coaster will do. Okay, so x, right, you ignore all of these with inequalities to begin with, so you just treat them. Certainly these ones here, you'll see why I'm leaving that middle one for a second, just as equals, okay? Now this one needs to be in the form y equals mx plus c, so I'm going to rearrange that by here. So I'm going to get 2y is equal to 8 minus x, and then I'm going to get y is equal to 8 minus x divided by 2. And then I'm going to create an xy table for that one. Let me squeeze that in, minus x over 2. So then choose any 3 values of x. 0, 1, 2, 1, 2, 3, up to you. I need to do one for this one as well, for the y is equal to 2x plus 1. 2x plus 1, isn't it? Yeah. So 0, 1, 2 for that as well. Okay, so in this case, x is 0 there. 0 times 2 is 0, add 1 is 1. And then 2 times 1 is 2 times 1 is 2, add the 1 would be 3. And then 2 times 2 is 4, add the 1 would be 5. So 0 and 1, 1, 2, 3, 4, 5. And then 1 and 3 there. And then 2 and 5 there. Okay, so you'd use a ruler. Should go through all of the points, and it needs to come all the way to the edge of the graph paper. Okay, label what that is, don't just leave it blank. Tell someone who it is who's marking your work. That's 2x plus 1. Okay, so it's going through plus 1, quite easy for me to work out. This graph is a dream to draw. That's one easy mark here. X is equal to minus 1. There's x minus 1. It literally goes straight through that point there. Okay, it's that one there. Obviously, if I had a ruler, that would have been perfect. Yours will be perfect. Okay, this one here. Now, I might have chosen silly numbers. You'll see why in a second. 8 minus x, so 8 minus 0 is 8. Divide that by 2 is 4. So 0 and 4 I can plot quite easily. But then 8 minus 1 is 7. 7 divided by 2 is 3.5. I'm not plotting that. I'm going to come up with a different number now in a second. It's going to be too hard to plot that. 8 minus 2 is 6. 6 divided by 2 is 3. So 2 and 3. So 1, 2, 3, 4, 5 would be there. Okay. Right, which one shall I use here? Now you can see actually it's not the easiest one in the world to plot because the rest of them are odd numbers. So in some respects, I'm going to have to go back and plot that as much as I didn't want it. But if I had like another nice even number, say I had 4 by here, I would have chucked in 4 there. So that's 7 divided by 2, which is 3.5. So I'm going to have to be really careful with my scale now. So 3.5 would be bang in the middle. There's 5 little squares here, so it must be 2.5 squares up. So 1, 2, 2.5 there. Okay, but it just means I have to be uber careful plotting that line, and then make sure that my ruler goes through all of those points. Okay. So that is y is equal to, now it's 8 minus x over 2. And it's fine to write that form, or you could write it in the original form, which was this one here if you want to do the same graph. Okay. Now we wanted the points where x was greater than or equal to minus 1. So that's everything this side of the line. So I shade the side we don't want. We don't want this side here. Okay. But the other ones are slightly more tricky to plot. I tend to think of a point, and I tend to try and think of this point in particular to see if it fits my range or not. Here, at the origin, the x is 0 and the y is 0. So I'm going to chuck x is 0 into both of these. So there. Now, this says 0 plus 2 times 0, which is 0, is less than 8. Is that true? Yes, that is true for that graph there, which was this one here. So this, the origin, is actually the side of the line I want. I want everything under this side of the line. So I'm going to shade the side I don't want, which is this bit here. Okay. And then finally, for this one here, for the 0 is greater than or equal to 2 lots of 0 plus 1. So that becomes 2 lots of 0, which is 0, add 1. 0 is greater than 1. That's not true. So this time, the origin is not the side of this line that I want. So I'm going to shade underneath this line here. Okay. There's another video on my channel. If you want to go and do a bit more work on this, have a look at that. I'll even see if I can work out how to link it to it. But it does state here, it says you must state clearly and indicate the region that you want. Okay, this is the region I want, so I just put an R there. Okay. Okay, lots of mistakes made on this one. It was quite a tricky one. So 4.5 there means that must be 4.5 there. It says the diagram shows a sector of circle of radius 4.5 centimeters. The perimeter of the sector, so that's the curvy bit, all of this, and these 2 bits in here, and then out there. So if I started by here, so doing, oh, that doesn't really work now, does it? Yeah, if I start by here, there, and then there, back to the starting point, then all of that is 34 centimeters. So what have I got to do that? I've got 4.5 plus another 4.5 plus the curve, or I shouldn't really call it curve as I'm a maths teacher. We should call that the arc, is equal to the perimeter. Okay, so I know 4.5 plus 4.5 is equal to 9. Add the arc would be equal to the 34. Now let's take that plus 9 over here, so it becomes minus 9, so 34 minus 9 would be equal to what the arc is. So the arc is 25 centimetres. Okay, now that's going to be really, really important to work out. If I want to know what the arc is, the curvy bit of a circle, the round bit of the circle, is called the circumference. But if I only have a bit of it, we do the angle out of 360, why 360? Because that's what's in the total circle, and you multiply it by the formula for the circumference. So that is pi times diameter, or 2 pi times radius. So pi times diameter, or pi d as I'll call it, is equal to the 25. Now I know what the diameter is. If the radius is 4.5, then 9 is equal to the diameter. So theta over 360 times by pi times by 9 is equal to 25. Okay, so from here now I want to start taking bits over. I'm going to take this times by pi times by 9 over and get theta over 360 is equal to 25 over 9 pi. Okay, now 9 doesn't go into 25, nor does pi. Leave that alone. We're now going to take that over 360 to this side here, and it would multiply the whole fraction, but that would just multiply the numerator. So we don't actually need to write it by the side. You can do if you want, but it doesn't make any difference. Now 9 does go into 360 because 9 goes into 36. So I'm going to cancel out the 9. I'm going to cancel out the 36 and change it to 4. Well, it's not 4 because it's got a 4 and a 0, so I'm going to cancel that out totally and say it's 40. And then theta would be equal, certainly over pi, 25 times 4 is 100, and then add a 0 would be 1000 over pi is the quick way to do it, okay? But I have done quite a quick method. If you're unsure, come and ask me in class how I did it. Okay, probably number 11, the hardest one on the paper as far as I'm concerned in terms of explanation stuff is it's not the easiest thing in the world to remember. Now, what I tend to get to do to my classes, for when we talk about the word similar, we say for length, for area, and for volume, okay? The small times by the scale factor will give me the large one, or the big one, okay? The same is true with area, but area, it's not scale factor, it's the scale factor squared. Now I'll go through this properly in a lesson as well at some stage. And then for volume, any ideas what it might be? It's times by the scale factor cubed, okay? Now it's actually worth writing that down in an exam when you get the chance, okay? Now, like I said, we'll go through this properly at some point in the lesson. So a metal bar can be melted down to form 875 ornaments. Now I'm thinking of an ornament, I'm just thinking something very generic. It's going to be three-dimensional, isn't it? I'm working with the volume here, so we're working scale factor cubed. I know that is a height of 6.3. Now to make the bigger one, obviously I'm going to use an awful lot more of the stuff, aren't I? Okay. Now that has a height of 31.5, so I need to work out the scale factor, which would be timesing by the scale factor that way and dividing by it this way. But to do that, I need to do 31.5 divided by 6.3. Okay, now I'm going to try and do what I think is a smart way of doing it, but you might disagree. You might want to run it through bus stop or whatever. I'm going to times both by 10, which is 315 divided by 63. Now I know that 3 goes into both of those because 3 goes into 300 and it goes into 15, so it must go into 315, and 3 obviously goes into 63 twice and once. Okay, so that goes in 105 times divided by 21, and then 21, 42, 63, 84, 105. So, sorry, 105. So that would be equal to 5. So the scale factor is equal to 5. So what I want to do here, now this doesn't strictly ring true for what I'm about to do, but it's certainly going to make sense, at least I hope it's going to make sense. If it doesn't, like I said, ask me in class. If I've got 875 of these ornaments, these small tiny little ornaments, I'm going to melt them down to make one big thing, and then I'm going to put them into bigger ornaments, and then it makes sense to me there's going to be much less of them. So what do I want to do with that scale factor? I don't want to times by it, I want to divide by it, okay? So I want to do 875 divided by the scale factor, but because we're talking volume, so 5, I have to cube that. 5 cubed is 125. Two ways to do this: divide top and bottom by 5, they clearly both have 5 going to them, or try and write out the 125 times table. So 125, double it, 250, 375, 500, and then that's what we're talking about, 625, 750, 875. There it is. 1, 2, 3, 4, 5, 6, 7. So the answer to that is 7 big ornaments. Okay, tricky question. I didn't think that was easy, so be careful with that. Like I said, we'll be doing some of that in class. Okay, to be a rational number, you need to be written as an integer. That means whole number divided by another integer. That's another whole number. Pi is not. Pi is a famous irrational number. 3.14, never ending, never repeating. If you put square root of 2 onto your calculator, it would just say root 2. It's absurd. So to do that question there, you can't. It's irrational. Okay. Cube root of 16. 16 is not a cube number, so that's irrational. Now this means cube root of the top number over cube root of the bottom number. Now these are both cube numbers. That would actually be 5 divided by 2. That's a whole number divided by a whole number. Hence it's that one. Okay. Squaring these would be 3 squared over 8 squared. That would be 9 over 64. That's fine. Square root of 144. That's fine. That's 12. Cube root of 64. That's fine. That's 4. That one there is, it says a never-ending, never-repeating number to be irrational. That, if it's got dots in it, is repeating. That means it will be rational. So by process of elimination, is pi squared. And the reason why 3.14 blah 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 times by itself 3.14 blah 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 is obviously going to be a rank disgusting number. It doesn't work out nicely. Okay. Okay then, frequency density. This wasn't easy either. You need to know a formula. Frequency density is equal to frequency divided by class width. I would scan through my exam paper and look for a histogram question straight away and write that formula down next to it. Okay, and so to work this out, I'm going to create a new column by the side called class width. So that's 10, that's 5, that's 2.5. Oh, this is going to be fussy. That's also 2.5, and this is back to 10. So the frequency 6 divided by 10 would be 0.6. This is 22 divided by 5. No idea. 22 divided by 5. Right. I know what 22 divided by 10 is. That would be 2.2, but that's twice as much, so that wouldn't be true. So I'm going to times that by 2 to get 4.4. Again, there's many ways you can do it if needs be. Go and do that if you need to. So 22 divided by 5 and work out what it is that way. Okay, and then this one here, 2.5 is into 15, well, I can actually count in that, so 2.5, 5, 7.5, 10, 12.5, 15, so that was 6, I hope. And then, oh, that's a fussy one, isn't it? 17 divided by 2.5. Okay, 17 divided by 2.5, okay, 170 divided by 25, times them both by 10, divide both by 5, would be, oh, not these one, 35 divided by 5, 7, is it? Don't feel like that can be right. I feel like I messed something up there. It can't be right. That's 14, that's why. And then into that would be 6.8 times. God, that was fussy. You saw me struggling with that, and I'm a maths teacher. Take your time, you know, if needs be, I would have written that as 25. With 17, 170 like that, and just take your time if you need to. Okay, I'm trying to just rush through it really quickly because it's Sunday and I want to have a little bit of my weekend free as well. And then finally, 15 divided by 10 is 1.5. Now, if you got those wrong, as long as you plotted what they were onto this, you would have got a mark for it. Okay, so make sure that you try and plot something, even if it's a case you have to plot it. Look at it at the frequency density. If you need to, make those up and put something in, because you'll get a mark for it. Okay. So between 480, I need 0.6, so the scale there goes up 2 in 10 little squares, so that means each little square is worth 0.2. So that is going to be 3 little squares up to 0.6, just sharpening my pencil. So I'm going to go 3 little squares to there. I'm going to have hopefully a nice straight line there. Oh, right. Can you tell me why that's wrong? I hope you can. Think about it. 480 to 490, so it needs to come all the way across to here. Now, what I'm finding already with my graph is that it's not really showing up, so I just shade it in if I was unsure. Okay, I was worried that it's not going to be seen. And then 4.4 would be 490 to 495, would be a whole 5-bar thing there. Again, if in doubt, shade it in, make it really stand out. Like so. Don't want to lose marks. You're worried that you're thinking it's not going to show up. Okay, 6 for this one. Now it's only 2.5 this bit, so I need to go halfway in, don't I? So 1, 2, 3, 4, 5. Halfway into 6. So I would use a ruler, but as I haven't got one, I can't really use one. 6.8, so 1, 6.2, 6.4, 6.6, 6.8, there. Okay. And then finally, this bit here, 500 to 510 at 1.5. I'm a bit fussy, this one, isn't it? So 2, 1.8, 1.6, and then 1.4, so it's bang in the middle there. That's where you really do need a decent ruler to make sure it really is obvious where you went. Okay, I think I've done an okay job there, though. There we go. Okay. Now this one here was already drawn for us, but we know the formula FD is equal to F over CW. We want to find out an estimate for the median height. Now this was really tough actually. This is possibly one of the worst questions as well. Get frequency on its own, because median is the middle, isn't it? We need to know how many there are, find the middle. So we divide the total by 2. Okay, so we need to know the frequencies. So this divide by class width will become class width times by frequency density is equal to the frequency. So read off what that is there. That looks like 1 to me. Let's be certain. 1, 2, 3, 4, 5. It is. So 1 times by a class width of 10. So there would be 10 people in this bar here. This one here would be 2.2 times by 5. Okay, times that by 10 would be 22, and then halve it, because I wasn't times by 10, I was times by half of that, would be 11. This one here, so let's read off properly, 6, 6.2, 4, 6, 6.8. So this one is 6.8 multiplied by 2.5. Oh, it's fussy, isn't it? 6.8 times 10 would be 68. Times by 5 would be half of that, so that would be 34. So times by half of that would be 17. So there's 17 people in this bar. This one here is 8. That's times by 2.5, so I'm going to use the same trick. 8 times by 10 would be 80. Times by 5, oh, I knew that one actually. That's a bit silly, wasn't it? And then times by 2.5 would be 20. That'd be true. Yeah, that'd be true. And then by here, this was 4.2, 4.4. This is 4.4 times by 5. So 4.4 times 10 is 44. So times by 5 must be half of that, which would be 22. Okay. So how many people did we have altogether? So 22, add the 20, add the 17, add the 11, add the 10. Comes to a total of 22, 20. I feel like I've gone wrong here. 2, 7 is 9, 10, no, it's fine. 10, 2, 4, 5, 6, 7, 8, yeah, it was 80. Okay, that's why, because I've marked all of yours, I know what the answers are, and I thought I'd mess it up. It's not 80. Now, if I'm to find the middle, I'm looking for the 40th person. So 80 divided by 2 equals 40th person. That's the median person. Okay, so there's 10. Now we're up to 21. We've got 21 people so far counted for. Okay, now we've got another 17 people on top of that. So that is now 38 people accounted for. 38 people means I'm 2 into this category here. So I'm between the 502.5. Now this is where some of you finished and it wasn't quite true. 502.5 is less than x is less than 505. Now I can use this formula here again to rearrange to work out exactly what the class width is. So the class width must be equal to the frequency divided by the frequency density. So I know it's 2 more people into this bar, and I know the frequency density, I'm reading that off, is 8. So the frequency, the class width must have been equal to the frequency, which was 2, divided by 8. 2 divided by 8 is a quarter, isn't it? It's 0.25. So it's 0.25 into that category there. So starting at 502.5, it must be 502.5 plus a quarter, which would be 502.75. Particularly nasty, that one there. You know, that's tricky. So yeah, bit of a nasty one. After Friday's lesson, I'm hoping that this one here will actually be quite easily done now. You should spot, hopefully, on the bottom a square number there and a square number there and a minus in the middle. means that is the difference of two squares. So you have 2x plus 7 and 2x minus 7 will give us that thing on the bottom there. To get the top, the way I do it is I times the front and the back one, which will give me 42, and they add up to 13. So I'm looking for a pair of numbers that times to 42 and add to 13. Got it, it's 6 and 7. Now the way I do it is I drop just the squared from that at the moment, but be careful. If you've got a way that works for you already, don't change now, it's too close to the exam. Stick with what you know. So 2x and 2x, just drop the squared from both. Obviously one of those brackets will have to cancel down because 2x times 2x is 4x squared. So one of these must cancel. Plus 6 goes in one, and then plus 7 will go in the other. Now obviously there's no number that goes into 2 and 7, so that remains as 2x plus 7, and this one would become x plus 3. If you use my method, you must cancel down. So on the top here, I've got x plus 3 and then 2x plus 7. Okay, now I can see there's something on the top and on the bottom because they're times them together. I can cancel down, which would give me a total final answer of x plus 3 over 2x minus 7. Okay, coming to the last one now. It says, calculate the probability that the chocolates chosen are both white chocolates. White chocolates, there were 4 out of a total of 10, 6 and 4 out of 20. That's how many there are the first time, but it says here that you take the chocolates and you don't replace them because you obviously eat them. So if I've eaten one of the white chocolates, that'd leave 3 in total left now, and it'd leave me 19 in total. 4 times 3 is 12, and then 20 times 19, 2 times 19 would be 38, add the 0 would be 380. Do not cancel that down, you get full marks for that. It doesn't say to cancel down anywhere, so don't bother. You could lose a mark if you cancel down and do it incorrectly. It then says here, calculate the probability that they are chosen are of different types. Now, you can start trying to list all the probabilities. The quickest way to do it is to do 1 minus the probability that I get a white and a white, or I get a milk and a milk, or I get a dark and a dark. Okay, that's the quickest way to do it. You could say, right, I could get a white and a milk, I could get therefore a milk and a white, and it turns out there's 6 different ways. This is a little bit quicker this way. We already know this probability. We know that's 12 out of 380. I now need to do the same calculations I did here for the 2 milk chocolates. So for the milk and the milk would be 10 out of 20 times by 9 out of 19. Don't try and cancel them down, there's no point. That is going to give me 90 over 380. And then the same for the dark and the dark. Show you what I'm doing. Dark and a dark would equal, what was it, there's 6 darks, so 6 out of 20 times by 5 out of 19. So that's 30 out of 380. Okay, add those together. 90 add 30, 120, 132. 1 minus 132 out of 380. Basically, if I'm doing 1 out of that, you just have to work out what the difference is between these two numbers, and it'll be over that to end with. So I'd add 8 to take that up to 140, and then that would be 240 to add up 2 altogether, so 248. Okay, lots of different ways of doing that, but that's my particular favourite. If you're unsure, like I said, ask me in class. Okay, last question. Okay, so the last question was transformations of graphs. This thing here, we've looked at this recently. If it is inside, it is moving it left or right. It's doing the opposite of what you think. I would assume looking at that +3 to move it on 3 places, but I do the opposite of what I think because it's inside. If it is outside, I move it up or down. I do exactly what I thought. So 0 comes back now to going through, -3, and 2 would come back 3 to be going through, -1, and it's literally just me picking up that curve and plonking it by there. So it should look exactly the same. Okay, now in terms of this thing here, the minus means it's a reflection. Okay, now it's going to either reflect in X or in Y. If worst case scenario, gamble rather than just leaving it blank, outside actually means reflection in X. If the minus was inside here, it would actually be in Y. Okay, so all I need to do is flip that graph there, like that. Okay, so that was the minus f of x plus 3, and the blue one was the f of x plus 3, and that was the entire paper.